Right, for this tutorial, I'm going to look at a variety of past paper questions on vectors, either that ask you to find a resultant vector, so I'll just show you some of the ones I'm going to be using. I've taken this from National 5 Maths, so either you might be asked to find a resultant vector, or you might be asked to find the magnitude of a vector, and you might have to find the resultant first. So because these often come together, I'm just going to put them in one video, and because it's all past paper practice, it's quite useful. So first one I'm going to use is this one here. Find the resultant vector 2u minus v. So anytime you have a vector, just make sure you underline them. If they're typed, then they can be in bold, but when we're writing them out, we have to underline them. So when u equals this one here and v this one here. So express your answer in component form. So component form is the form that these two are in right now. So 2u minus v. So I'm just going to write each of those vectors out first. So u is negative 2, 3 and 5. And v is 0, negative 4 and 7. So we have 2u minus v is what we've been asked for. 2u minus v. So finding the resultant vector is really just what's the result when we do 2 times u and subtract v. So I'm going to write down 2 times, and I'm going to now replace u with these components here. 2 times minus 2, 3, 5, minus, and instead of v, I'm going to substitute in this here. 0, negative 4, 7. So I've substituted in the components for u and v. Next thing I'm going to do is I'm actually going to find 2 times u. So you just multiply each component by 2. So 2 times negative 2 is negative 4. 2 times 3 is 6. 2 times 5 is 10. So that one becomes negative 4, 6, 10. Minus 0, negative 4 and 7. And then so for this one, I'm going to write this out in full. We then subtract each one that corresponds in place from each other. So for the first component, this one here, we're going to do minus 4, minus 0. Next one, we're going to have 6, minus this negative 4 here. So I'm just writing it all out. And then 10 minus 7 on the bottom. I'm just going to close that bracket. So I'm just going to find the answer for each of those. Negative 4 degree 0 is just negative 4. 6 minus the minus 4 becomes 6 plus 4, which is 10. 10 minus 7 is 3. And so the resultant vector when you do 2u minus v is minus 4, 10, 3. And that's you. All right, let's look at the next past paper question. So this one says, 2 forces acting on a rocket are represented by vectors u and v. U is 2, negative 5, negative 3, and v is 7, 4, negative 1. Calculate, and now these little lines here are the magnitude. It actually tells you there. The magnitude of the resultant force. Express your answer as asserted in its simplest form. So we've actually got both things here. We need to find the resultant first, and then we'll be able to find the magnitude after that. Writing down our vectors, I've got u, 2, negative 5, negative 3, and v, 7, 4, negative 1. So we've been asked to calculate the magnitude of the resultant force. So before we find the magnitude, I want to just find the resultant first of u plus v. U plus v. So as we just did in the previous one, I'm now substituting in what u is, plus 7, 4, negative 1. So we've got 2 plus 7 on the top, so 9. Negative 5 plus 4, negative 1. Negative 3 plus negative 1, so that goes down to negative 4. So we have 9, negative 1, negative 4 there. So to find the magnitude, this comes from Pythagoras, so you are finding the square root of each of these components squared and added together. The magnitude is just how long is the vector. So we're looking for a number at the end, and we're squaring these here partly to make them positive so we can actually see the length. So 9 squared plus negative 1 squared plus negative 4 squared. So we're squaring each of them added together. So just be careful, 81 plus 1, so we need it to be positive, plus 16. So putting that into our calculator, 81 plus 1 plus 16 gives us 98. So the square root of 98, you might just want to actually write square root of 98 equals, and it actually says, oh, I've just realised this is a non-calculator paper, so ignore that I just used my calculator to work out what square root of 98, adding 81, 1 and 16. So square root of 98, we now want to simplify this as a surd in its simplest form. So if you're not sure how to simplify surds, you might want to go back and have a little look at that tutorial. So we're looking for two numbers that go into 98, with one of them being a square number. So you might have noticed that 49 times 2 is 98, so we can do square root of 49, square root of 2, square root of 49 is 7, so it's 7 root 2. And that's the magnitude in its simplest form as a surd. Right, let's look at some more vectors questions. Right, this one here. This is a paper 2 one, so find u with 2 lines either side there, that's the magnitude, but it does tell you specifically the magnitude of u. Let's just write down our vector. U underline, don't forget to underline it, is 6, negative 13, 18. And so the magnitude is going to be the square root of 6 squared plus negative 13 squared plus 18 squared, which, this is a calculator paper, you can put it straight in. So square root of 6 squared plus brackets, negative 13 squared plus 18 squared is 23. And so the magnitude of that vector is 23. Right, I'm going to do one more like that, and then I'm going to do one that's slightly different. So two vectors are defined as u and v. There. Find the resultant vector for u plus 3v, and then in part B we're going to be asked to find the magnitude. So we'll do part A first. So writing down these vectors. So slightly different here, we only have two components, 2, negative 5, and v is negative 4, 3. Nothing's different if there are two numbers there or 3. So we've been asked to find the resultant force of u plus 3v. So we're just going to substitute in what we've got there. So u is just 2, negative 5, plus 3 times, and v is negative 4, 3. So we're just going to work out what 3 times that one is first before we add them together. So we have 2, negative 5, plus 3 times negative 4 is negative 12, and 3 times 3 is 9. Adding them together. 2 plus negative 12 on the top, so same as 2 minus 12, which is minus 10. Minus 5 plus 9, which is 4. So we have negative 10, 4. This is a paper 1-1. So on the next part, part B, so we've found the resultant force of u plus 3v. We've then just been told find this. So you need to be able to recognise that if you have these two lines at either side, that means the magnitude. Up until now it has actually stated the magnitude. If not, you just need to know that that's what these two lines either side mean. So the magnitude is the square root of negative 10 squared plus 4 squared, square root of 100 plus 16, which is the square root of 116, and then we need to think if we can simplify that surd at all. So you're looking for any square numbers that go in to 116. So if you can't think of any others, you can maybe just do 4 here, because it can be square root of 4 times, let's just check, 116 divided by 4. That goes in 2 times, yeah, so 29. So 4, 29, which then square root of 4 is 2, and actually we can't simplify square root of 29, so the square root of 4 was the highest one there. So the magnitude there is 2 root 29. Right, I'm going to do one more here. This one, slightly different. We're asked for the resultant again. This is from the 2015 paper. The vectors P and Q are shown in the diagram below. Find the resultant of P plus Q. So this time we're not being given it in component form, we've actually been given a diagram of these here. Express your answer in component form. So we do need to write it in component form at the end. So I'm going to show you two different strategies that you can use, partly so that we can revise how to draw these added together. And I'm also going to just show what we could do if we were to put it in total component form. So P, we're looking at P and we can write it in component form. We look at where it starts. So you can see that it starts here because the arrow goes that way, so that must be the end. And you almost do it like you would coordinates. If this is the start, we go along first and then up and down afterwards. So to get up here, we're going to have to go 1, 2, 3, 4, 5 to the left. So writing that down in component form, that will be -5 first. And then we finished here, we're going to go up 3, 1, 2, 3. So that's going to be a +3 because we've gone up. So P in component form is -5, 3. Q in component form, so it must start here because the end is down here because the arrow's going that way. So to get there, we're going to go along to the right first. 1, 2, 3, 4. So that's 4. And going down, you go 1, 2, 3, 4, 5. So 4, -5. Right, once you've got it in component form, we know how to add it in component form. So I'm going to do it that way first, and then I'm going to show you how we would do it through the diagram of them adding together. So down here, we're going to have P plus Q, which is -5, 3 plus 4, -5. So -5 plus 4, -1, 3 plus -5, -2. So the resultant here, find the resultant of P plus Q, express your answer in component form. This is our answer here, -1, -2. So we can actually do it, you could do this in the exam anyway to check that you've done it correctly, but just need to remember that if you're adding two vectors together in this diagram, then we've got P, this one's already been drawn for us, plus Q. So you have to top and tail them. So we're going to draw Q, but at the top of P, which is here, because that's the tail would be where you start, at the top of P, I'm going to attach the tail of Q and draw it joined together. So let's do that now. So we're going to start here at the top of P and I'm going to draw Q. So remember for Q we're going to go 4 along and 5 down. So I'm just going to count that from here. 1, 2, 3, 4 along, 5 down. 1, 2, 3, 4, 5. And so I'm going to draw that line there. And that is Q. So I'm just going to label that Q. So the resultant we actually get from joining, where we started was here, where we finished is here. So you just make sure that you're actually, the arrow's going in a whole journey there. Our resultant is this one here. Now it's important to get this arrow correct. So this is the start, and we went along here and along there, and that's the finish. So that's the same for this one. This is the start, and that's the finish, so it's going in this direction. If your arrow's going around in a little triangle and you can go there with it going backwards, then it's not right. That must be the start, that must be the finish. So this here is P plus Q, and we can see from the diagram that if we were to do this in component form, you'd go 1 to the left, so that's -1, and then down to -2. So if we take it from the diagram, P plus Q is -1, -2. Same as we got from our other method. Just to add a little extra in, if you were to find the magnitude of this, just so that we're practicing, the magnitude of P plus Q. So we've got -1, -2. Don't forget you do the square root of -1 squared plus -2 squared. So -1 squared is 1 plus -2 squared is 4. So the magnitude of that in third form is the square root of 5. And that's a little bit of revision on finding a resultant vector and a magnitude and a little bit of drawing vectors as well.